Hello Internet, my name is Quinn and this is Blondihacks. One of the most common questions I get asked is what brand is your lathe and what should I look for when buying a lathe? Well, I'm going to answer, I guess that's two questions. Well, I'm going to answer all that and more right now. This video is premised on the idea that you've decided to buy an Asian import lathe new. Now, I'm not going to get into the conversation of should you buy like an old American or an old British machine versus buying a new import tool. That's a whole separate conversation. There's lots of good reasons to do one or the other, but I'm assuming you've decided to buy new and Asian for some of the advantages that a machine like this has. First and foremost, it is new, so you don't have to worry about the ways being clapped out. Second, depending on who you buy from, you have a good chance of getting support and parts when things break. And you have a good chance of getting a manual and being able to buy tooling for it. And, you don't have to worry about, is there a steady rest, for that beautiful Logan that you found in a garage or whatever. So those are all great reasons to buy new and Asian. And so we're going to assume that that's what you are here for. The first rule of Asian Club is you don't talk about Asian Club. Wait, no. The first rule of Asian Club is don't judge a book by its castings. If you're looking at all the different brands of Asian import machine tools, you will find lots of machines that look identical and are just different colors. And that's because there's some factory, probably in Shenzhen, that's making these casting sets and selling them to the budget machine tool companies. But that doesn't mean that they're the same machines. You'll find the same set of castings in use on machine tools from Sieg and Jet and Grizzly and Harbor Freight and yes, Precision Matthews, but that doesn't mean they are the same machine. The bearings can be different, the slides are different, all of the details can be different. The industry of import Asian machine tools is a lot more complicated than just China bad, America good. These machines are built to whatever specs the loud Americans are asking for. Someone like Harbor Freight is just importing the cheapest machines they can find and repainting them, but other companies have relationships with those factories and they're making special requests and working with those factories to, control quality and get special features added for, for their market. So that's why you do get what you pay for. So don't fall into the trap of seeing what looks like an identical machine at Harbor Freight that's, half the price of the one at Grizzly or whatever and assuming that they're the same machine because they're probably not. First and most important decision you have to make is size. Lathes are generally measured in swing and distance between centers. So this is a 10 by 22 lathe, which means that it can swing an object 10 inches in diameter in the chuck. Swing as in you can put it in the chuck and spin it and it won't hit anything. And then the 22 is the distance between centers. Now, like most things in life, those numbers are lies. You would probably never actually want to swing something 10 inches in here. 5 or 6 inches is the most that I would probably do because once you're swinging something large, your power goes down a lot, but we'll get to that later. And then that 22 inches between centers number, well, sure, in principle, but by the time you get centers and chucks and taps and other lathe tooling in here, that working area drops down quite a bit. So, they say you should get the biggest lathe that you have space for, and that's a lot of why, because those numbers are all smaller than they seem on paper. And make sure you look at the spec sheet for the machine that you're interested in to get the overall dimensions because, for example, the size of the headstock varies a lot. So a given 10 by 22 lathe, might be 40 inches long or 50 inches long in total outside dimension. And you also need as much space on this side of the headstock as you can afford because you need room to stick long stock through the spindle. And you also need access to the change gears and to replace belts and things back here. So generally speaking, you can snuggle up the tailstock end to a wall or something, but you need plenty of space back here behind the headstock. The next thing to think about for some markets is Imperial or metric. And if you are outside the United States or Canada, this is an easy decision. You go metric. But if you are in North America, the decision is not so obvious. So you might ask yourself, well, which is better? Go ahead and figure out which is better down in the comments there. I'll wait. Hold on, gotta wait for the gunfire. Okay, cool. Now that you guys have figured that out, the reason that it's less obvious which to use in North America is because, frankly, there's still a lot of Imperial everything in America. So your stock and your tooling and your fasteners, all that stuff's easier to get in Imperial in America. All the metric stuff is available, but if you want to go all metric in your shop here in North America, you are going to be swimming upstream a little bit, and so be prepared for that if you want to sort of take the high road, as it were. Now, everybody has their opinions on this, but personally, I think it's not actually that obvious which system is universally better for all things. I think both systems have advantages. In the home machine shop, at the kind of model maker scale of machining, I find actually Imperial is easier because all of your dimensions are in thousandths, which gives you nice integers. Tolerances and sliding fits and so on are all nice small integers. If you're doing metric on smaller scale parts, you're dealing with a lot of decimals of millimeters, 0.37 millimeters and so on, and it's just much easier, I think personally, to work with 40 thousandths, 50 thousandths, and so on. The advantages of metric, however, are in many areas, including like taps and dies, drill sizes, and fasteners. All of those are much, much simpler and cleaner in metric. The Imperial drill size system is ridiculous and nonsensical. So, there's plus and minuses to both. The other advantage to Imperial in manual machining in a hobby shop is that a lot of the best books on manual machining were written a long time ago before metric was invented. So if you're looking at like old project plans or old project or machine shop instructional books that you might find at flea markets and stuff, they're all going to be in Imperial. And so it's actually really handy to be able to use those references because the techniques of manual machining have not changed very much in the last 100 years. And so the information in all those old books is still really, really good. But if you're having to convert everything to metric, or if you're building a steam engine from a plan that you found in a book, it's all going to be in Imperial, and converting all of that to metric without losing all of your tolerances and fits is actually quite difficult. So yeah, for those reasons, Imperial has a lot going for it, more than the internet would have you believe. But if you are going to go Imperial on an Asian import machine, make sure you know what you're getting, because of course these machines are all built metric, and they sort of convert them to Imperial for us silly North Americans. So there's different ways that they do that. The cheapest way that they do it is just by replacing the markings on the hand wheels, but they leave the original metric lead screws in here. And so what that will do is give you weird numbers of rotations for measurements. So on this particular machine, one lap of this hand wheel is exactly 200 thousandths on the cross slide. And that's really nice because it's easy to measure distances, and you can easily make deep cuts without having to lose your place every time you do one lap around this dial. On some of the cheaper machines, you'll get 90 thousandths or 112 thousandths is one lap of this dial. So what you want to look for if you're going to go Imperial is a machine where they've actually put Imperial pitch lead screws in it. So this is a Precision Matthews machine, and they do put Imperial lead screws in these guys at the factory, which is why the hand wheels all have nice even multiples of 100 thousandths on them. The next decision is power. Now, if you're looking at Asian import hobby machines, you're probably not looking at three-phase, but there are still two major choices. You've got AC motors in these guys, and you've also got brushless DC motors in these guys. And both of those have different advantages. The main advantage of brushless DC, and the reason that all of these machines have gone to that, is that the power to weight and power to size ratio of BLDC motors is very, very good. So for a relatively small motor, you can get a lot of power. So this is the motor out of this lathe, and it's quite small and light, but it's a full horsepower, 750 watts. To give you a proper sense of that, this is our 1 horsepower brushless DC motor, and this is a 3/4 horsepower AC motor. So you can see that it's much, much larger and a lot heavier, but actually less power. But the other big superpower of brushless DC motors, and the reason that I recommend them for all small machine tools, is that you get this real-time speed control for free. Now, if you're not familiar with how BLDC motors work, there's no mechanical brushes in them, but there are effectively virtual brushes. So the stator has multiple poles on the motor, and each one is a little electromagnet, as you would expect. But instead of there being a commutator with physical brushes touching it to switch the polarity of those stator coils as the motor spins, there's a computer circuit in there with MOSFETs that's doing that switching electronically. So it's just energizing the coils in sequence as the motor spins, and it's using a Hall effect sensor to monitor the velocity of that spindle so it knows which coils to enable and how fast. So since you're doing all of that work electronically anyway, throwing a potentiometer in there to vary the speed is basically free. And this is actually incredibly powerful in machining because it allows you to do things like vary your velocity while you're facing. So if you're facing off a very large part, you can increase your velocity as the cutter moves in and get a nice even finish all the way across the part, as opposed to a traditional lathe that doesn't have a real-time speed control where you have to pick a crappy compromise on surface speed for facing, so you end up with a part that's spinning a little too fast on the outside and a little too slow on the inside. To better illustrate these differences, it helps to understand the power physics of these two different types of motors. So here's the torque curve graphed against RPM on the bottom there for a typical AC motor. And AC motors have this great property in that they have 100% torque at 0 RPM. And that's something that no other type of motor or engine can do. And you'll see that it holds that right up to a point where the torque falls off pretty dramatically. So the advantage of an AC motor in a machine tool is that the motor is designed to run at a particular RPM where the torque is maximum, and it stays running at that speed all the time. And the speed of the actual spindle in the machine is adjusted with gearing. And so you've always got the maximum torque available. The other advantage to that is that when you're running at lower RPM, you're gearing down, and so you're gaining the torque multiplication that you get from gearing down. So at lower spindle RPM, you have more torque available, which is usually what you want in that situation. Here's that same data for a brushless DC motor, and it looks about the same, right? Well, there's two things hiding in this data. First of all, at high RPM, the torque falls off a cliff. And that's important because unlike the AC motor that's operating at a constant RPM, the BLDC motor is operating at varying RPMs depending on the spindle RPM that we want, because we don't have the advantage of the gearing to control the RPM of the spindle. So that means if we want a high spindle RPM, we don't have that torque. And so in BLDC machine tools, you typically have a belt system of some sort for when you need higher RPM so that you're not subject to that negative torque area. But then the disadvantage of that is because you're gearing up to get that RPM, you're losing a lot of torque. The other sneaky thing hiding in this data is that you'll notice the RPM doesn't start at 0 like it did on the AC motor chart. And that's because of the efficiency curve of BLDC motors. At low RPM, the efficiency falls off a cliff. And that means to maintain torque, we need huge amounts of current, and the driver boards can't deliver that. So the bottom line is, because we don't have the advantage of gearing for torque multiplication, we're kind of at the mercy of the physics and what the driver board is capable of delivering. These BLDC motors have a more limited RPM range within which they have usable torque. Next, you want to look at what the drive mechanism is for the power feed on the carriage. Almost any lathe, even those little 7x14 mini lathes, have a power feed on them, but there's different ways that these lathes get that done for different price points, and some of them are really bad and some of them are really good. At the lowest end, the most inexpensive lathes just use the lead screw to power feed, and they just rely on these threads, and there will be a half nut lever, and you engage that half nut and that clamps down on the threads, and that drives the carriage. The big disadvantage to that, of course, is that you're going to wear out the threads on your lead screw. This lead screw is arguably the most valuable thing on the lathe, perhaps second to the spindle bearings. And you don't want to wear this guy out, because then when you do need to go and cut single point threads, you want this guy to be precision. So I would avoid any lathe that relies on the lead screw threads to drive the carriage. But it's not just about wanting to minimize wear on these threads. There's a nasty mechanical Faustian bargain hiding in trying to use the lead screw that way. The RPM of this lead screw is controlled by some combination of a transmission, a quick change gearbox, and change gears that ultimately drive the lead screw off of the spindle. Now the problem is that these change gears are really intended for creating the right ratio for single point threading. But remember that threading is basically a very aggressive form of power feeding, right? Even the finest pitch thread that you might cut, say a 24 or 28 threads per inch, that's still way more aggressive than you would use for actually power feeding while you're turning. So what that means is that these gears here are sized to be about as big as will fit in here for a fine pitched thread. So if you're going to try to put gears in here that drive this lead screw slow enough for power feeding, the gears out here have to be huge, and there's never enough room in here. So the upshot of all that is that those small lathes that use the lead screw always end up just running too fast. They feed too quickly, and that limits the depths of cut you can use, and it limits your ability to work in harder materials like steel and so forth. At the high end, which you'll see on larger machines, is a drive shaft. So there will be multiple shafts here. Some will be control shafts, one of them will be the lead screw, and one of them will be a drive shaft, and it'll be a shaft that runs the length of the bed and goes through the carriage, and it's just spinning. And then there's a gear system and a clutch inside the carriage that allows it to grab onto that shaft and use it for power. And the advantages of that type of drive system are that it doesn't involve the threads on the lead screw at all, and so there's no wear on those threads from regular power feeding, which you do a lot of. Luckily for us budget-minded home shop machinists, there's a great middle ground, and that is the keyway drive. So on a machine like this, there's a keyway that runs the length of the entire lead screw. And then inside the carriage, there's a key that engages with this keyway and uses it to tap power off of the lead screw. So that solves both of our problems because we're not relying on a half nut engaging with these actual threads to drive the carriage. So we're not wearing out these threads. And then because there's a key riding in here, that key can move independently of the speed of this shaft because it can just slide in here as it needs to. And so that means we can have additional gearing inside the carriage that allow us to control the speed of the carriage independently of this lead screw's rotation. So the power is tapped off this keyway and it's driving gears inside the carriage, and then the carriage is ultimately driven by this rack under here. And this is actually the same mechanism used in the higher end machine tools that use a dedicated drive shaft that runs parallel to the lead screw. So this is a very clever compromise. And so while your rate of power feed is still set by this quick change gearbox, inside the carriage there can be additional down gearing that makes the carriage move much slower than it otherwise would if it was relying on the threads of the lead screw. Now on the subject of power feed, pretty much any small lathe is going to have power feed on the carriage, as we said. But some of these higher-end small machines also now have power cross-feed. And that can be really hard to tell from pictures because they're all going to have some sort of power feed clutch lever like this guy. But it may not be obvious that, this guy can engage the carriage, but then also has this other position, which on this machine engages the cross slide. So this is where you really got to study those spec sheets and download the PDF of the manual to find out what features are really in the machine. And if you're scouring photos to try to deduce what features are present, don't confuse the power feed clutch with the half nut lever. Make sure that it's got both. Okay, next we get into some of the more kind of quality of life things to look for. A big one is locks on the slides. There's surprising variation in all these Asian machines on which slides have locks and how good they are. You really want to look for locks on all the slides. If you're used to, big floor standing lathes, it might be comical to even think that there wouldn't be locks on all the slides, but this is one of those areas where these Asian machines will cut corners. So you want to check for that. Now it is possible to add locks if you have a machine that you really love and that's the only thing missing. It's not a deal breaker. You can just drill holes and tap and put your own screws in there and make a lock. But this guy does have locks on all three, which is nice. But it's not enough just to have locks. You also want them to be well designed. So for example, this guy here is the carriage lock on this machine, and it looks great. Nice big Allen head cap screw, no problem. Well, what happens when this cross slide moves back a little bit? Suddenly this gib adjuster is blocking it. So if you're in the middle of, let's say, turning to a shoulder and you get to the end and you want to quickly lock the carriage and wind out to face the shoulder, well, depending on where the cross slide happens to land, you may not be able to get to that lock in that critical moment. It's usually fixable. So in this case, I made this special wrench here, which is just a piece of scrap that's very flat with an old piece of Allen wrench pressed into the end of it. So that guy sits in there, and this guy just lives in there, and it clears those gib adjusters, so I can always access my carriage lock. But these are the kind of things that'll bite you. And here's the cross slide lock on this machine, and you can see it's an identical cap screw to these gib adjusters. So it might be hard to tell from a photo that this guy does in fact have a cross slide lock. So again, that's where you really want to download the PDF of the manual to double check. But now an area where these budget machines often skimp is the compound lock. A lot of them don't have one. And you might think, well, how often do you really need to lock the compound? Well, the biggie with this guy is that it's great to be able to lock it when you need extra rigidity, for example, when parting. And being able to lock slides that you're not using to increase rigidity is really important on these small machines because rigidity is something they don't have a lot of, so you need all that you can get. So being able to lock every slide that you're not using when you're doing a particularly demanding operation like parting is immensely valuable. So don't underestimate the value of a compound lock. Now again, if there isn't one, it's pretty easy to just drill and tap a hole in here and make your own lock, but it's nice if you don't have to. Another quality of life area where these import machines tend to cut corners is on the accessories. So, a lot of these machines will come with a steady rest and a follow rest, and make sure you do get these because they're important. But often what you get isn't very good. The follow rest on this guy is okay. The steady rest that I got with this machine was honestly pretty awful. All of these slides are all seized up. I had to dismantle the whole thing, deburr everything, clean it all up. And the big T-bolt that mounts this guy to the ways doesn't actually fit between the ways when it's turned. So the only way to install this guy is to dismantle this whole thing and try to thread it up from underneath, and your hands get filthy in the process. Or you have to slide the tailstock off and slide this thing on from the end. And because it's a one-piece design and not a split opening design like you'd see on a larger lathe, it's quite difficult to get this guy arranged around your stock. You have to do a lot of fiddling with these very fine pitch screws. And once it's set up, you're pretty much committed. You can't open it, remove the stock or change your setup and expect it to be repeatable when you put it back in. So yeah, these accessories tend to be serviceable, but not great. Another big quality of life feature is the quick change gearbox. Now, that term means something different on these small Asian machines than it does on a bigger machine. On these small import machines, what it means is if you're lucky, you've got 3 speeds here and a forward and a reverse here. And this gives you a nice selection of power feed rates, and it gives you the ability to cut left-hand threads and power feed in both directions. But on bigger machines, a quick change gearbox generally means you get some or all of your single point thread cutting pitches also available in this transmission. That is not the case on these small Asian machines. If you are going to be single point thread cutting a lot, you are going to be messing with these change gears. So the way this works is that there's a special set of change gears that's intended for power feeding, and it's basically the largest set of gears that will fit inside the case. So that combines with the 3 ranges that you get here on the quick change gearbox to give you different power feed rates. And again, because of the keyway drive, we can just barely get away with this. We have just enough space for the largest gears that'll fit here, combined with a little bit of down gearing in here, and then additional down gearing in the carriage that gives us a slow enough feed rate that we can actually do real work in things like steel on a small machine. So let's talk about these change gears a little bit more, because this is another area where they really cut corners on some of these machines. You will often find plastic gears in here. And, depending on the power of the machine, that may not be a big deal. If it's a low power machine, say 1/2 horsepower or something, honestly, a good quality plastic gear is going to be fine. So this is a 1 horsepower machine though, and it's got these sintered metal gears. So that's kind of a nice feature. They are not machined gears, but they are at least metal. So that's nice. However, the fit and finish on these is, again, another area where they really cut corners. So the first time you go to change these gears, you will find out that in the factory, they didn't ream anything, they didn't deburr anything, they didn't polish anything. And so the fit of these gears on their respective shafts and bushings is very poor, and odds are they hammered them on in the factory. And so you may in fact need a puller to get them off the first time, as I did, and then you will probably need to spend a few hours deburring and polishing and reaming out all of these holes so that everything actually fits the way it's supposed to, as I also did. So the reality is that because of the hassle of these change gears, you are probably not going to do a lot of single point thread cutting on a machine like this. But the good news is, because it's a small machine, you're making small things, and so 99.9% of the time you can just use dies, and you don't have to worry about having to mess with these change gears. But there's a little gotcha there. If you're relying on dies for most threading operations, that means when you do need to single point thread, it's probably for something weird. Some kind of really fine pitch or some kind of odd pitch, or maybe it's a metric thread when all your dies are Imperial, or however that goes. So what that means is you want to check the manual before you buy to make sure that all of the change gears that come with the machine can be set up to do all of the weird threads that you might want to do. Okay, but we got to talk about the elephant in the room, the most important part of a lathe, the spindle bearings. The quality of these guys, of course, largely dictates the quality of everything that this machine is going to produce. Now, we haven't talked a lot about this yet because honestly what it boils down to is very simple. You get what you pay for. The more money you spend on your machine, the higher quality those bearings are likely to be. At this price point on these Asian import machines, they're all going to be zero maintenance sealed bearings, and so you just use them until they fail, and then you take the headstock apart and replace them when the time comes. Because they're not serviceable, it's important to be nice to your bearings, so don't overheat them, don't use push-style knurlers that are going to put a lot of stress on these bearings, all those sorts of things. Another important quality of life thing is the tool post. You really want a quick change tool post. These Allura style tool posts used to be very expensive, and they are still more expensive than the old-fashioned 4-way or other simpler tool posts. So this is another area where a lot of the lower end machines will cut corners to keep the sticker price down, but you're going to end up buying one of these anyway. And honestly, these things have come down so much in price, and these Asian clone tool posts are really very good. These tool holders from China are, again, really frankly very good and very inexpensive, so there's no reason reason not to buy one of these, and the quality of life improvement from a quick change tool post just really can't be overstated. So you definitely want to get one of these. If it's not included in the price, add it to the price before you start comparing. One of the little weirdsies that you want to watch for is the chuck mounting system. These budget Asian machines never have a nice standardized chuck mount. They don't have a nice D1 cam lock or something so that you can go buy a new Bison chuck and just mount it on there. That never happens. They all have some weird custom system. This particular guy, you loosen these nuts back here and then you rotate this ring and this guy comes out. So if you want to put new chucks on here, like maybe you want to, get a collet chuck, but collet chucks don't come with this particular brand. So what you can usually do is buy or make a backing plate, and then you have to make your own mounting for this guy. So this is a bit of a hassle, but it's just an unfortunate limitation of these small machines. But it's definitely worth looking at the manual before you buy to see what this mounting system is, because some of them are really awful. Some of them require getting access to Allen heads that are inaccessible, and it's like a 20-minute job to change the chuck. You want changing the chucks to be quick and easy because you're going to be going back and forth between 3-jaw, 4-jaw faceplate quite often. So it's an important quality of life thing that this be pretty easy to swap. But before we wrap this up, I want to address those 7x14 mini lathes specifically, because a lot of people are interested in those. They're very tempting because they're very inexpensive and they look pretty much like real lathes. So the question is, are those things any good? Well, the short answer is no, but the longer answer is it depends. The truth is you can do some decent work on them. There are YouTube channels out there dedicated entirely to 7x14 mini lathes, and especially in brass and aluminum, you can do some nice stuff on them if you have good tooling and if you know what you're doing. It's a bit like how a good musician can play good music on a dime store ukulele just as much as on a $6,000 Fender, right? It's the same thing with machining. If you're skilled and you're careful, you can do good work on a crappy tool like that. But it is a lot harder to get good results. And it's a lot harder, I think, to learn because you don't know when you're making a mistake and where you're just encountering a limitation of this machine. So the bottom line is you do get what you pay for, and you should buy the most expensive lathe that you can afford. The more expensive a machine that you have, the more enjoyment you will get out of it and the better results you will get. But do remember, when you're buying a machine, you should budget 50% of your money for tooling is the rule of thumb, and it's a very good rule. You will easily spend as much as the lathe cost, again, on tooling. So think about what your budget is, cut it in half, spend the lower half on the machine, and expect to spend the upper half on tooling. The good news, though, with tooling is that you can buy it gradually over time, so you don't feel that cost quite as much. But yeah, definitely do buy the biggest, heaviest, and most expensive lathe that you can afford and that will fit in your shop. So that's all the basics of how to buy an import Asian lathe. I hope you found this useful. Consider supporting me on Patreon, and we'll see you next time. Thanks for watching.